Hi, everyone. Thanks for joining. It is day 3 of the AI Agents Assemble Hackathon. I am very excited. We have, by the way, crossed 5,000 registrations, and the Discord is going crazy. So happy to see that. People building stuff. Hackathons are always fun. So, third stream of this week, we are joined by Zain from Together AI, and we're going to learn about LLM agents. So, tools, memories, best practices, a lot of practical examples. As you have joined the previous streams, feel free to send in your questions. We will be answering those in the end. Before we get started, Zain, do you want to give a quick intro about yourself? What do you do? What does Together AI do? And then we can kick it off.
Yeah, for sure. So let me, I work at Together AI. I work as an engineer on the developer experience, developer relations team. Um, and basically what we do is work with developers that want to build with language models, build with Gen AI models, and make sure that the platform has everything that you need to go and build your app end to end. I also work with the research teams to make sure that the work that they're putting out is relevant and usable by a lot of the developer community. So I work on developer education. And so today, mainly what I wanted to talk about is uh, what makes an agent or what allows you to use an LLM to power an agent. So in the talk, actually, I'll get into what Together AI does and who our customers are and things like that. But yeah, that's a little bit about me. And
Amazing. And by the way, they're also giving away $2,000 of credits to the winner of the hackathon. So you want to check out the rules and everything on the website. It's all on the website, go check it out. But if you have any other questions about the event, you can shoot it on Discord. The team is active there. And yeah, let's learn about Together AI and LLMs and agents and everything. I'm going to share Zane's screen and then we can kick it off. Zane, over to you. And by the way, everyone, send in your questions in the chat. We'll answer in the.
awesome. Thank you. Okay, cool. So let me just see if the slides are working. Okay. Um, so I wanted to talk about, what an agent is, and then I wanted to go into how you can build these agents as well. Um, so this is roughly what we'll cover. I don't have to cover everything. So if there's really interesting questions in the chat, then we'll jump over to those. But yeah, I'll roughly talk about defining what an agent is, why it's different now versus a year ago, and how things are changing. And then I'll talk mainly about the building blocks for agents. A lot of people might have heard about this, but I'll talk about function calling and um, some best practices around how to do function calling well. Then I'll talk about some ideas around practically implementing agents, what models to use, what capabilities and properties of the models to use to build good agents, and then we can get into the Q&A. A little bit about me, I already gave an intro, but one thing that I'll mention here is if people have questions, we'll take it at the end. But if you have questions afterwards, you can reach out on Discord. I'm part of the channel, but um, you can also reach out on my social media handles as well. So I'm always happy to chat with folks that are building in the space. Okay, so I mentioned I talk about Together AI and what we're working on. Together AI is an AI native cloud. One way to think about us is effectively if you're building any Gen AI model or if you're building with any Gen AI model, you're going to need a platform that understands, runs, trains that model, and Together AI provides such a platform. We provide everything from kind of bare metal GPU chips all the way up to the actual engine that allows you to run those models as quickly and efficiently as possible. And so that we're basically an AI native cloud that allows you to build with and build Gen AI models. One of the reasons why I decided to work at Together was because it gave me the opportunity to work with folks that are leaders in the field. So working with people that are actually building this technology and then deploying it. And so it's been an awesome experience over the last about year and 2 months now that I've been here working with these folks. And we pretty much cover the entire stack. Like I mentioned, we're supporting people that are building these models all the way up to people that are building apps and deploying apps using these models as well. Because we serve everything from entire GPU clusters to the ability to fine tune these large models. So, for example, you can take a Kimi K2 type model that's a trillion parameters and you can fine tune it and deploy it on these GPUs. Or if you just want to use these models for inference, you can just call one of the 200 plus leading model APIs that we have, and you can just use that particular model. And you can use it in different form factors, right? If you want kind of real-time performance, we've got the fastest inference endpoint. If you want to perform evals, or if you want to kind of submit batch jobs, we've got a batch inference endpoint. If you want to use different modalities, we have everything from video, images, voice, to language models. And we're kind of always making sure that we have the latest and greatest on the platform for people to be able to build with. Okay. And this is kind of a testament to all the different companies that are using us. Uh, Companies all the way from kind of these model builder labs like Hydra that makes text to video models, all the way up to AI native companies that are using these models, right? So, for example, Recept that's building a computer using model, um, uh, Quora, and these companies. Okay, with that, let me talk a little bit about kind of how you can build agents on the Together platform. So this talk was designed to kind of demystify the idea of large language model agents. Um, and so, what I mainly want to cover is what is an agent from scratch, right? And then hopefully that way, when you're building agents, you're understanding all of the components that are going in, and when something is not working, it's a little bit easier for you to debug what could actually be happening and what's not working with the agent. Okay. Um, So this is kind of how I understand agents in general, and then I'll come to uh, the whole world of language models and all of that in a second. But the main idea, how I think about agents, is you've effectively got this kind of uh, character in this game, this world, and this character has been spawned into this world, and their job is to kind of win the game. Right? Like any game, you want to have a strategy, you want to play the game, you want to avoid the things that will lose you the game or give you negative reward, and you want to do the things that are positive. And so in this case, the agent is effectively just going to play this game. And because this is a relatively simple game, the strategy is quite simple as well, right? You kind of want to you're always spawned in at the same spot, and then you have some fixed strategy that you'll learn very quickly to win the game. And and mainly what you're learning is to avoid these bad states that you don't want to end up in, which stops you from winning the game. Right? And so, if you think about what an agent is doing, I would argue that even a large language model powered agent is effectively doing the same thing as what you're seeing on your screen right now. Right? And this is how classically in the field of reinforcement learning, agents have been understood for decades. Right? And now we're starting to see how language models are being understood in the same manner, and not even just that, but they're being trained to act as agents using the same algorithms that these more classical agents were used to be trained. Right? And so, effectively, if we kind of dive a little deeper into what this agent is actually doing, it's just building up a understanding of what states the game can be in as a result of its actions and how it benefits from those states. Right? So effectively, it's looking at where it is on the board, where it is in the world, and then it's looking at, okay, what are the actions that are available to me based on where I am, and then it's saying, okay, if I'm in a particular state, let's say I'm at the start of the state, doing a particular action gives me some reward, right? There is some value that is associated with this action when performed in this state. And in the beginning of the game, because the agent doesn't really know about the world that it's in, it'll have a really bad map of what's good and what's bad. So it'll make moves that seem random or non-optimal. And then by the end of the game, when it's perfected this mental map of how to what to do in which state, it'll have a very good understanding of what's good and what's bad and which moves to make. At which point, it's become an expert. And for this simple game, it'll be relatively easy. It doesn't need to play that often to get better. And so, effectively, what the agent here is doing is trying to understand the world, right? And they're kind of going about performing actions. These actions are up, down, left, right on the keyboard, and the environment then responds by giving it some reward that says, good move, bad move. This is the reaction that the environment has to the move that the agent took. Um, and then the state is updated as a result, and that's fed back in to the agent to say, okay, what are you going to do next time? You took this move. This is the current state. This is the reward that you got. Now tell me what you're going to do next. And you keep on kind of going in this cycle until the agent wins. And so effectively what the agent is doing is it's learning, which actions achieve rewarding states. What are good states to be in? I used to play a lot of video games professionally even. So the main thing when you're learning to play a video game is you want to build up a strategy on how to put yourself in a rewarding state, in a winning situation, and how to put your opponent in a losing situation. Right? And so that's effectively what this agent is doing as well. This is another example of an agent where you're effectively kind of I can play this video where in this case you've got some agent that is going about and interacting with objects in the real world, and then depending on the actions, it'll get reward or it'll get negative feedback. This is another example of an agent. And so if people remember a long time ago, the OpenAI gym was an environment that allowed you to train these robots to do kind of natural tasks like walk or jump or go from point A to point B. This is also an example of an agent. Right? And so it's about at this point of the talk where people start to go, I thought this was going to be a talk about language models, and that's what everybody else is talking about, the idea of using language models as agents. But I would argue that everything that I've said so far um, applies is a good framework to understand how large language model agents work as well. Right? And so if we think a little bit about kind of fitting language models into this framework of how agents operate and work, we're going to need to understand how language models work, right? And so language models are token in, token out type of kind of models where you're effectively passing in tokens, you're asking them questions in the form of tokens, and it's giving you some answer in the form of tokens as well. Right? And so anybody that's used ChatGPT is kind of understand this input-output type of framework. But if we ask a slightly different question here, where if we say, um, what is the weather right now? Now a language model, um, if it's not connected to the rest of the world, doesn't have a good understanding, right? If it doesn't have a weather API that it can call, then it can't really give you a accurate answer or the correct answer to this question, right? It can tell you, right now it's December, and approximately in December, this is what historically the weather in Paris has been like because it's got kind of some understanding of this information, but it doesn't really know what the weather right now today on December 10th is. Right? And so, in order for a language model to get access to real-time information and kind of do things in the real world, there's something missing with the language model. Right? And so, a language model by itself is not an agent. So the question is, what more does it need? Right? And I think it effectively just needs one thing, right? But this thing is really general. This idea that it should call something, call tools in the real world, and then incorporate their response into its answer is what I would argue an agent is. Right? The language model now has the ability to kind of take in questions or text as input, then make a tool call, and then incorporate the response of this tool call into its answer. And so here, you're affording the language model the ability to interact with external tools and APIs before it has to generate the output text. Um, and so now it's got this language model has some agency to call an API or to find out something in the real world, perform an action, learn about something before it has to give you the response. So now you've taken this language model that operates in token space, looking at input tokens and outputting the response tokens, and now you've given it the ability to interact with real world environments. For example, you could connect this language model to a 3D printer, and it could send the 3D printer some CAD file, and then it could send it a kind of an API call to say, go ahead and print it. Right? It can actually do things in the real world. And so if we think more concretely about what this could look like, this input-output uh, paradigm of the language model will stay constant. What will change is the universe of tools that we give the language model access to, right? So if the tools we give it access to and how we train it is relevant for coding, if we train it to be good at coding, or if we give it access to software engineering tools that allow it to read a file, edit a file, search within a file, then this kind of framework will turn into a coding agent, right? This is what for example, Cursor or Klein or these types of agents are kind of doing, right? So in this case, if you look at Klein as a software that's built around language models, effectively you're giving it the ability to read files. If you're telling it, here's an issue on a GitHub repo, I want you to submit a PR that can resolve the issue, that can kind of code to fix the problem. It needs access to kind of tools that allow it to understand what's happening in the repo. So, for example, it'll start off and it'll start to read the files within that repo to build up a good understanding. And then it might want to kind of search through the files to get exactly the files that are related to the particular issue. And then it wants to edit those files to implement the change, right? Because what's there right now is not working. So it might want to edit those files. Let's say you have a different type of agent. You have an e-commerce agent. Now, notice how this backbone is still the same. The only thing that's different is now the universe of tools that this language model is connected to and can call before it has to answer. So in the case of an e-commerce agent, it might have the ability to perform an order action for the customer that it's talking to. It might have the ability to perform a return action, and this could actually be kind of a bunch of tools that are embedded within it, but let's just, for simplicity's sake, we'll say that it can perform a return action. Or if things get kind of hard to do, it might also have a human in the loop escalation tool that it can call to connect the customer to an actual human. Um, and so this is effectively what agents are. They're language models that have the ability to call these tools. And so in this case, we need to add one more thing, right? This idea of having one input and one output is good, but it simplifies the tasks that you can perform. Right? If you take this same input-output backbone, which is like kind of straight going through this, where you have some input, the language model says I'm going to use a tool, and then you have some answer. But if you allow the language model to go and use this tool in some iterative format before it has to answer, now you've got this kind of n iteration tool use loop, and now you can solve problems that are slightly more complicated than a problem that would require one tool call. Right? And so in this n iteration loop, you can have multiple tool calls that build up on previous tool calls that allow you to solve a longer task. If we go back to the example of looking through an issue on a GitHub repo, um, if it's a complex issue, you'll probably not be able to solve it with one tool call, right? There's not one file you need to edit, or there's not one kind of search functionality that you need to perform. But instead, what you need to do is kind of understand what the high level task is, and then you need to, maybe the first thing you do is build up a plan. You call a kind of a planning tool to understand what I need to do, what the plan is, and then start doing that plan. So you need to call one tool at a time to perform those actions on that plan. And then only when you've gone through this iteration maybe 10, 15, 20 times do you realize, okay, now the job is done. The final tool that I've called gives me the final kind of code that I can commit for the human to verify. Now I can go in and say, okay, the job is done. Here's the final response. What do you want me to do next? And so using these loops allows you to perform more difficult, longer horizon tasks. And so at this point, I would argue that we have everything we need to understand what a LLM powered agent is. Um, And so in this case, if you want to understand how this works, how this workflow kind of works step by step, where I take you through every tool use and look at the response, I have a code notebook here that you can look at. And in general, if you're building with LLMs and you want to understand how to perform different actions, I've built out this um, kind of Together Cookbook repo where you can go in and look at code that actually explains how this workflow works. And in general, here we've kind of built out cookbooks that allow you to build agents, that allow you to perform evals, perform fine tuning, all sorts of different types of fine tuning, from preference tuning to continual tuning, long context tuning. Um, it teaches you how to do RAG and search, and then all sorts of other examples focusing on uh, code execution, enabling language models to run and execute code, how to do summarization, how to do kind of a PDF to podcast loop. So as you're going about in the hackathon, I suggest you look at this repo to kind of understand how to build these more end-to-end types of workflows just with access to a large language model API, maybe a embedding model API, a re-ranker API, images, video, all these different modalities of models. Okay, so kind of getting back to this idea of what an agent is. Um, the community is pretty much kind of converged on this definition of agents, where it's a LLM that runs tools in a loop. This idea of that going and not being able to perform the entire task in one pass, but rather having the ability to call tools iteratively in this loop before the goal is achieved. Right? And so um, a lot of different kind of research labs and people that have been working in the field have kind of come to this definition now, where this is one example. This is from Simon Wilson, who's kind of um, uh, who blogs, and he uses a lot of these language models, and so I follow a lot of what he puts out kind of religiously. This is another institution, the Meter Institution, that studies long horizon tasks and how able language models and agents are at completing those tasks. And they've been kind of studying the capabilities of language models all the way from GPT-2 times, where they weren't that capable, now to kind of have your Claude 4.5, Opus 4.5, Sonnet, GPT 5.1, that sort of thing. Um, and they're studying effectively what type of tasks these language models can complete end to end. Right? And so this is actually a log graph, where if you take the y-axis and you kind of put a log through it, this now becomes a log linear trend, where effectively what they show is that the ability of these frontier language model agents to perform long horizon tasks um, has been doubling approximately every 7 months, right? And so the idea here is that for GPT-2, you could give it tasks that maybe took a human 30 seconds to perform, and it could do it end to end. So things like searching an API, or calling an API that allowed it to Google search for some fact. Right? And now if you go up this y-axis, you're now increasing the time that it would take a human to perform these things, right? So for example, training a classifier. So um, if you've trained a classifier before, even a classical model like, for example, a random forest or something like this, you'll know that it takes some iteration, some time to get the hyperparameters right, to run experiments to see what's working, what's not working. And so let's say that takes a human 1 hour. These models can now actually go end to end and perform this task. Actually, if you go through that repo that I shared, Together Cookbook repo, we've got an example of this in there where, let me just go back and show folks. So here, so in this case, if we go to Together Cookbooks, and if we go into the agents repo, and we go into the data science agent, we actually build out this Together data science agent end to end, where we talk about how you can give it kind of complex data science questions, and it can go about performing these, right? So if you go through this one by one, at the end, you'll actually be able to have an agent that visualizes data. And this is kind of a stock example where we look at a very simple data set, but you can even give it more complex data sets, and it can go through this loop of kind of visualizing. Here, I've just given it a high level tasks. It loads up the data, it visualizes it, understands what it needs to do next, and then it says, okay, next what I want to do is maybe fit a classifier to this data, right? And then it goes about this multi-step process of solving this problem. And so we tried this out on everything from classical models and data sets to more complex pipelines, where you give it kind of a more difficult task, it breaks it up, and then it goes about executing it. It's kind of visualizing this iteratively. And you can even give it a budget to say, you have 20 steps to solve this problem. And then depending on how hard the problem is, you can increase that budget or give it an open-ended budget to keep on kind of iterating. And so it can do really cool things that classically data scientists have worked on. You could give it even your own custom data set and ask it to just explore and fit a classifier or fit a regression model to that data set and kind of look through the trace of everything that it's performing. Right? And so when we looked at this, we actually gave this agent really complex problems, and kind of it's not that it always gets it right, but the idea that it can make a mistake, realize that it made a mistake, and then go back and then try to kind of fix the mistake that it did, right? And so this was a really interesting kind of look into how language models can go about exploring a data set, working towards fitting classifiers and regression models onto that data set. And so this was a really interesting project that we worked on. And so in this case, if you think about kind of this idea of language models going end to end, training classifiers, training models that classically humans have trained, these models now have the capability to do so. And I would argue all they're doing at the end is effectively kind of this iterative loop that is kind of has been understood very classically. So now what I'm going to do is present this from the perspective of an LLM agent, right? So now your agent is effectively your favorite large language model, um, and the actions that it has, that it can do, are these tool calls. So in the case of a coding agent, it has the ability to search a repo. It has the ability to edit files. It has the ability to kind of execute code and look at the response, right? It can run a test. The environment takes those tools that the agent performs, that it outputs, and it actually runs them, right? So the environment I kind of think of as all the software engineering tools around the large language model that allow it to that parse the tool call that it wants to run, and it runs the tools, and then it gives the response and the updated environment back to the agent, and the agent now kind of keeps on this treadmill of what's the next tool that I need to use to get closer to my end goal. And so now the environment is it, you can the environment is larger than this, but effectively for simplicity's sake, you can almost think of this environment as taking the tool that was used, the response from it, adding it back into the context of the language model, and the language model says, okay, now that the world is updated, what do I do next? Is the task completed, or is there still some work to be done, and then I can kind of keep on going in this loop? And so effectively, this is what an agent is. Right? This ability to run a language model in this iterative loop-like manner, and it can execute one tool after the other, looking at previous tool executions, and you're letting it go until it completes the task. And so one thing that I wanted to deep dive into here was the ability to do function calling, right? If functions and tools are the way that language models action things in their environment, it's pretty critical to understand how this works, right? And I would argue function calling is the single most important thing um, for agents to work, right? If you can make sure that they call the right functions, or if you train them to call the right functions in the right circumstances, a large language model will be a very good agent. If it can't do function calling, then you'll run into all sorts of issues, right? So if we think about what function calling is, it's still tokens in, tokens out, right? It's nothing. It's nothing more complicated than that. But now what I've done is kind of added the special tokens that the language model always sees, but are parsed out so that you and I don't see it when we use a software product. And so here I've got some special tokens that identify what the start of the message is, who's talking right now. So right now the user is talking, what their question is, what the end of the user message is, and then what the start of the assistant message is. And then when the language model speaks, it also utilizes these tools to identify kind of, this is my answer. I've now answered the question. I've now stopped talking. Right? And so all these models, depending on who's trained them, use these special tokens to identify whose turn it is, who said what do I need to do now, right? And so in the case of function calling, it's also using these special tools, right? If we think about how function calling works, you have a developer, or you've got some ecosystem that the language model is embedded in, and then you've got this language model, and now the developer or gives it some high level task, right? It says, in our case, what is the weather in Paris? And then it gives it access to a tool that allows it to answer that question, right? And now the model needs to realize, I don't know what the weather in Paris is right now. There's nothing that I can do that would give me access to this information, but I do also have access to this function that I can call that would allow me to get real fresh information, and then I can incorporate that into my answer, right? So now what the model needs to do, what it should do, is call this tool with the appropriate parameter, right? So just as you and I would call a Python function, the model needs to realize the only way for me to complete this task is to use this tool appropriately with the correct location, which is from the question, by the way, and it then calls that tool. And because a language model is just a token output machine, it can't actually do anything. It can't actually call a tool. So what it says is, hey, developer, I'd like for you to call this tool for me. The developer then goes ahead and runs that function and gets the answer and feeds the answer back into the language model, right? So it's got kind of this tracking history, this messages list of previous interactions, and then it's got this updated information, which is the output of this model, and it goes back to the language model. And now the language model says, okay, based on this information, what is the final response, and it gives that back to the user. Right? And this is one turn of the tool calling, function calling iteration. If your question is relatively simple, this is all that's required to solve the problem. If your question is slightly more complex, you need to kind of do this over and over again. Right? And so if we take a look at how function calling works on a token level, you can actually go through this. So I built out a a Colab notebook that you can run for free. But the idea here is that I'm doing tool calling with a Quen 600 million parameter model. And so if I zoom in a bit, I go through this tool use example where I define tools. Tools are just Python functions in this case, and here they're very simple Python functions. They're just returning kind of fixed numbers. And then I import, I'm just using the Hugging Face Transformers library. I import this 600 million parameter model, and it's going to run in a free instance of Colab. I give it a high-level task, and then I also define for it the tools that it has access to. Right? So here, I've also given it access to these tools, which are just these kind of these Python function definitions over here. And this is what the model sees as input, right? So these are the special, this is the input prompt that the model sees, along with these special tokens that that are slightly different for every model. But here, the model sees, okay, this is the start of the message. This is the system prompt. The system prompt has embedded inside of it the tools that it can call, right? So these are kind of JSON tool definitions where it knows what the name of the tool is. And what's really important here is that it also needs to see a description of the tool to identify when to call it and when not to call it, right? And then it has an understanding of what parameters it needs to use to call that tool, and then the descriptions of those parameters as well, right? And then not only that, but we also tell it, how to do a correct tool call. So in this case, we give it an example of a correct tool call where it has to output a JSON object. It has to wrap that JSON object in these tool call tags over here. Right? And so it needs to start the tool call here, end it here, and then go forward. Right? And so we're teaching it what tools it has access to, and also how to call those tools. And so now if I pass this through the model and I ask it this question, what is the temperature in Paris? This is the output. So this particular model is a thinking model. It's a hybrid model. So here it thinks a little bit, but then it realizes, okay, if in order for me to correctly solve this problem, I need to do a tool call. And how do I do a tool call? Well, the system prompt tells me I need to do this open tool call tag, so the special token. I need to output this JSON of what tool to call. So this is the name of the tool, and this is the parameters that I need to pass into the tool. So this Paris, France, and unit Fahrenheit, and then that's the end of the tool call. Right? And this is all the model is doing. It's not actually calling the tool. It's actually just telling the user, I intend for you to use this tool, and that's it. Right? And so here, if we think about this on a token level, as I've kind of gone through, you're going to take all the input, tokenize it, and then pass it through the language model. The language model is then going to output its own tokens, and those tokens are effectively just the tool call itself. You can parse this out and then call that tool, and then depending on what the response from that tool call is, you can feed it back into the model, and now it has to use that information. And so here in this case, your messages list is the context that the agent has, right? It's this kind of list that's ever growing that has access to all the other tools that the model has, which tools were called, what are the responses from those tools. And you keep on appending the previous tool and the responses to that tool at the end of that messages list, right? And this is just one turn. Um, for agents that are solving difficult problems, they can do 20, 30, 40, 50 turns worth of tool calls before it gets to the final response. And the very first problem that you'll run into when you do this type of tool calling agent workflow is that you'll run out of context, because effectively what you're doing is over and over in this loop-like manner, you're appending one step of the agent action to this messages list, and you're doing it over and over until the task is completed. And so here, no matter how long your context is, whether it's 200,000, a million, 2 million tokens, if the task is complex enough or the tools that you're using are verbose in the sense that they give you a lot of tokens every time you use them, you'll run into this context length issue really fast. Um, we've only talked about one turn of tool calling, but for more difficult tasks, you almost have kind of 20, 30, 40, 50 tool calls. And effectively what you're doing is building up this messages context list, and you're just appending things to it until the this messages list has a token count that is larger than the context length of the model. At which point you have to perform some compression compaction action in order for you to go into the next turn of that agent. And so if you want to look at a kind of a concrete practical example of how to build out a coding agent from scratch using nothing but a large language model API, you can actually go through this example. And maybe this is what I'll stop at. But we built out this guide that takes you through kind of just a basic LLM API call, and then you can kind of go in, build a chat around it, where the chat is just kind of iterating over this language model, calling the model, and it's just taking the history of everything that's happened, and it's appending it to this messages list. Right? And then I go from kind of using this model as a chat bot to now exposing tools to this model one by one. And because I want to build a coding agent, I have to give it access to tools that allow it to read files, write files, so on and so forth, right? So here I'm defining these Python functions that allow it to read a file, that allow it to write to a file, right? And so one by one, I expose these tools to the language model, and now it can kind of read files. So because it has that access to a tool, I create a secret file that has some secret inside of it that the model would only be able to access if it could use this tool. And then I tell it, read the file and reveal the secret. And so now it has to tell me to use a tool, which it does. So when I call the language model, it'll output this, which is a tool call. I parse this, and then I call the tool. I give it the response, and now it has to answer. Right? And so here, there's the actual action of calling the tool. And then here's me parsing that tool, where I look through and see what the name of the tool is that it needs to call. And then I actually call the tool, and then I give it back the response, and then it now has to kind of use that response to answer the question. Right? And so if you go through this workflow, effectively what I'm doing is just exposing more and more complicated tools, language model behind an API, and it's using it to answer my questions. And effectively, when you're training a language model to be a better agent, you're just exposing it to this environment where it has access to thousands of tools, and then seeing how often it calls the right tool for the task, and you're changing its weights so that it does it more and more often. So if you think about these really powerful open source large language models like GPT-OSS or Kimi K2, GLM, Quen, um, DeepSeek v3.2, they're trained to just call the right tool depending on the task, right? And look at the previous tool calls and determine what the next tool call should be so that it can solve that task. Um, and so this is kind of a simple version of this agent environment that you're building yourself so that you get a more fundamental understanding of what it takes to build these tools. Um, okay, so maybe what I'll do is I'll go into questions now, and then we can hopefully that'll be useful for folks.
Amazing. Thanks for sharing. And we have a question. Do we make or train or fine tune LLMs, or do we need to make AI agents? I'm not sure I get that question.
Yeah, me neither. I think maybe this is like a hackathon specific question. Yeah.
Yeah, I mean, up to you. We have a lot of sponsors, and the problem statements can be found on the website. Yeah. There's one question. Does an LLM models take more time and lots of data to get trained? How can we train a model in the span of 5 days for this hackathon?
Yeah, I
It's a
think
good question.
that's a good question. So I don't think people are anybody's expecting you to train your own model. What
Mhm.
could be doable within a 5-day time frame, and it's easily doable, is to isolate a data set of maybe 1,000 prompts, 2,000, 3,000 prompts, and fine tune a model to specialize on a task that you care about, right? So all you need to do And if you go to the Together cookbooks repo, we actually have an end-to-end
Mhm.
fine-tuning guide that kind of walks you through how to curate the data set, how to format it, how to fine-tune a model, how to assess before and after. That's very doable. You can even do that in 1 or 2 days and maybe do multiple iterations of that to get to the final response. Um, and effectively, what you're doing there is taking a already baked, prepared model, and now you're specializing it on the 1,000, 2,000 examples that you care about for this hackathon. And now you're fine-tuning or specializing the model's capabilities for that domain. And that's very
Cool,
doable.
cool. Awesome. A lot of more hackathon specific questions. Please ask those in the channels. I think we're closing in on 15 minutes now. So just to be cautious of everyone's times as well. And of Zane's, we're going to wrap it up here. This is, by the way, being recorded because I know people are taking part from over 15 countries and the time zone doesn't work for everyone. So if you're watching the recording, um, you can do that. And yeah, any questions you have, send it in the Discord channel. You can join the Together AI community as well. And I've shared some Together AI resources on the website as well. All the links can be found over there. This was awesome, Zane. Thanks a lot for the presentation. And it was really clean and nice. Really appreciate you giving your time. Thank you so much.
Awesome. Thank you so much, folks.
Thanks everyone for joining. Have a great day. Bye.
Have a great day. Bye.